This is Jung Jung from KAIST. This is a collaborative work with Sungyoung Lee and Professor Gukjin Yoon. We present RAHA, rank-aware hyperbolic alignment for vision language dataset distillation. Uh, this work starts from data-centric AI. Dataset distillation asks whether a large dataset can be replaced by a very small synthetic one while retaining its training value. The goal then is not just storage reduction. The synthetic data must preserve the signals that actually generalize. In unimodal distillation, this is essentially semantic compression. A few synthetic images or text summarize useful structure from a much larger dataset. With visual language, there's only one more requirement. We must preserve not only each modality, but also how images and texts correspond. This cross-modal relevance is our main target. Prior methods have two limitations. Most align representations in flat Euclidean space, and they treat feature directions uniformly. But vision language semantics can be hierarchical, and image-text correlation is not equally strong in every direction. Raha builds upon two observations. Shared image-text structure is often low rank, while hyperbolic geometry naturally represents hierarchy. Raha combines these two ideas. Hyperbolic geometry models the structure, and rank tells us where alignment should be concentrated. At a higher level, um, Raha represents semantics in hyperbolic space, identifies the dominant shared subspace, and concentrates alignment there instead of matching everything equally. In each distillation step, we sample real and synthetic pairs, lift their embeddings onto Lorentz hyperbolic space, estimate their real cross-model structure, decompose it into dominant and residual components, and update only the synthetic data. The synthetic image is optimized in pixel space. For language, we optimize continuous text embedding, giving the synthetic text more freedom than discrete tokens. The first objective is hyperbolic image text contrastive learning. We lift image and text features onto the Lorentz hyperboloid and use geodetic space distance for similarity. Matching pairs stay close and mismatched pairs are separated, now in a geometry best suited for hierarchical organization. The second objective is rank-aware relevance matching. We map the hyperbolic features to the common tangent space at the origin, where cross-covariance and SVD are well-defined. SVD identifies an adaptive dominant range from the real image text cross-covariance. Raha strongly matches relevance in this range while regularizing the residual separately. This is the core of the selective alignment. We evaluate on Flickr 8K, Flickr 30K, and MS Code using very small synthetic budgets with retrieval, transfer, classification, and robustness tests. For image text retrieval, Raha becomes more effective as the synthetic budget grows. At larger budgets, it improves over strong baselines and produces cleaner synthetic images with fewer artifacts. The distilled data also transfers better to unseen vision and language encoders, suggesting that Raha preserves semantic structure rather than architecture-specific artifacts. Using image and text perturbations, the results are more mixed. Raha helps in some regimes, but not uniformly, so robustness is supporting evidence rather than our main claim. On prompted image classification, Raha also improves across the shown benchmarks, indicating transfer beyond retrieval. Qualitatively, Raha produces cleaner synthetic images and avoids many structural artifacts seen in distribution matching baselines. The ablations support the design. The dominant range contributes more than the residual. Hyperbolic geometry is important, and the adaptive rank remains stable while varying across datasets. To conclude, Raha makes 2 points. Alignment geometry matters, and alignment should be selective. Hyperbolic hierarchy and rank-aware relevance matching let us preserve the most useful cross-model structure in a compact synthetic dataset. Thank you for watching. Please visit our project page for the paper, code, and additional details. Thank you.